Hi everyone, I'm Yumna and my advisor is Professor Paula Cesari. In this video, we are going to explore how actual touch and our knack for imagining actions comes together in the world of social interactions. In social situation, our brain talks to our body through something called sensory motor interaction. It works like this. First, our senses like seeing, hearing, and feeling gather information from what's happening around us. Then our brain processes this information to understand how to respond. Finally, it tells our muscles what to do. So, that's how our brain and body works together to communicate with people in social situations. In the realm of cognitive neuroscience, Aristotle's ancient wisdom is true. Without touch, it is impossible for animals to exist. The loss of this sense alone must bring death. This statement underscores the immense significance of the sense of touch in our survival and cognitive functioning. In the field of cognitive neuroscience, we recognize that touch is a foundational sense, crucial for our ability to navigate and gather essential information. Without it, our survival would be greatly compromised. In our daily life, we use touch in various ways, like shaking hands to connect with others or soothing ourselves with self-touch. Sometimes we encounter uncomfortable objects. We also touch different surfaces like ATM screen or mobile phones to perform tasks. Every touch, whether coming from non-living or living things, provide information that can trigger positive or negative feeling. Our brain processes this input and guides our actions accordingly. This study aimed to explore how our brains respond to touch during social interactions versus non-social situations, shedding light on neural mechanism behind social behavior and touch perception. Participants visualize themselves exerting force because motor imagery mimics actual action in the brain. We also assess personal traits related to social interactions through a questionnaire. We had participants imagine applying 3 Newton of force with their index fingers. We explored 4 touch conditions: self-touch, where they touched their own index finger; V-touch, where they were touching another person's index finger; surface touch, where they were touching a hard surface; and a no-touch condition. In all touch conditions, they have to imagine to apply force from their index finger. We administered a questionnaire and stimulated the motor cortex in each condition. To stimulate motor cortex, we use transcranial electromagnetic stimulation coil that generates an electric signals, activating the motor system. This signal travels through the spinal cord to the target muscle, where we measure muscle activation in real time using electromyography, specifically motor evoked potentials. We focus on the index finger as our main point of interest, while using the little finger as a control. Let's dive into the results of our study, specifically focusing on the main muscle of the index finger, where participants imagine forceful touch interaction with themselves or others. Higher map amplitude indicated increased primary motor cortex activation. Conversely, when touching non-living object or in a no-touch scenario, map amplitudes were lower, suggesting reduced motor cortex activity. These findings emphasizes the role of social touch in engaging the motor cortex. Let's shift our focus to the control muscle. So, in V-touch condition where subject touched another person's index finger showed significantly larger map amplitude compared to the others. Further analysis revealed a negative correlation between map amplitude and the personality trait related questionnaire, particularly related to the touch avoidance. These findings suggest that those who showed a tendency to avoid touch also exhibited higher maps. This may reflect an inclination to move their hand away to avoid uncomfortable sensation associated with touching a stranger. In simpler terms, what we have learned today is that when we imagine doing something, our brain gets more excited when touch is a part of it, especially in social situations. And surprisingly, this brain activity changes based on how social we are as individuals. Thank you for joining us on this journey of discovery.